Today, we're doing the big 3 upgrade. If you guys have been following my channel, you've seen the video where I installed dual electric fans from FLEX-A-LITE in place of my original mechanical fan. You've even seen me take out my stock 105 amp alternator in place of this PowerMaster 140 amp alternator. What you didn't see really was my wiring situation. This is a 4-gauge wire that I picked up from a hardware store. It's more of a starting wire. It's more of a coarse wire where there's not as many strands of copper, but they're just thicker. Then I also grounded the back of the alternator with this 6-gauge. You can see the 6-gauge goes right up to the negative battery post. Now this red wire is my main power source for my FLEX-A-LITE monster fans. And it comes down here, you can see, to a fuse block. That's a 40 amp fuse, and all of this was supplied directly by PowerMaster in the kit and installed per the instructions. So I know that none of my wiring is installed wrong. This power cable goes directly to the positive post on the battery, and the fans are also grounded directly to the negative post. The problem that I'm having is I'm popping my fuses here. And not only am I popping my fuses, check out these babies. This was the first one to go. 40 amp fuse, completely melted. I've never seen anything like this before. This was the second one where the fuse actually blew before it completely melted. And so I decided to throw a 50 amp in there, and of course, same thing happened. It didn't blow, but melted completely. Let me know if any of you guys out there have used these fuses and if you've had similar results. I went up to my local O'Reilly, and as you can see, this fuse is a little bit different. That fuse is by a company called Little Fuse. From what I've heard, they've been around forever and make great products. I drove around for an entire day with this fuse in there, and it has not melted or anything like that, so I'm hopeful that the only reason why these were melting was due to maybe an inferior plastic on the fuse. All right, so now that all of that is out of the way, the point. What's the point? The point is that my voltmeter, I'm still having a power issue. My voltmeter is going from about 14 volts upon startup. I pull out of my garage, I take off, it'll stay about 13.8 to 14 volts. As soon as I crank my AC on, the dual electric fans turn on, my interior fan turns on, and my voltage, as long as I'm driving, will stay in the about 13.8 volt range. As soon as I come to a stop while I'm still in drive, that sucker drops all the way down into the red zone. So I know I'm having an issue. I'm trying to figure out what that issue is. I've already put in a call to PowerMaster and to FLEX-A-LITE. What I'm thinking is it might be my wiring. After doing a little bit of research online, watching a lot of YouTube videos, I found the big 3 upgrade. Now I kind of thought I already had done it with this. I ran the power line a lot thicker than the stock one, and I also grounded the back of the alternator directly to the negative post of the battery. I'm thinking though that I have a wire issue in terms of the wrong type of wire. I think I used the wrong wire. From the research I was doing, the type of wire you're supposed to use is a very fine threaded wire, meaning there's lots of little tiny strands of wire in a thick gauge. So once I learned that, I thought, okay, problem solved. You know, I just need to go get new wire. Then there presented another problem. Where the heck do I find this wire, right? I see on YouTube a lot of people are using that super thick gauge stuff that's meant for like stereo systems and speakers, which is fine. I think that's the exact same stuff that I got, except that stuff's like $7 a foot or $10 a foot, and I don't have that kind of money. So what I did was I figured out that if you go and buy what's called welding wire, I went to a place called Airgas, and they have this wire that's meant for welders to go from the electrode down into the welding unit, and it is the same exact thing. Really thick gauge wire with really fine threaded copper. So I decided on 2 gauge. I got 2 gauge wire, and here it is. The wire I got is by a company called Radnor. It says made in the USA, and I got 2 gauge, you can see here, which is good for 250 amps up to 25 feet. That's way more than I need, way more than I need. This was a 25-foot roll, and I only paid $50 out the door with tax and everything, so that comes down to about $2 a foot. And this stuff looks great. Tons and tons of strands of copper in there. Last thing before I get started actually working, I did call PowerMaster, as I had mentioned, and I talked to them about possibly getting a smaller pulley for this alternator to have it spin faster at idle. The guys were awesome up there, and he's going to send me out a smaller pulley. I think it's the smallest one that they can make for this alternator. This is a CS130 alternator, by the way, 140 amp, and it's I think the pulley is going to be 1.9 inches thereabout. I did also shorten this belt. I shortened it to, I think, probably as small as I could get. I did notice that after I had put in this new alternator, the pulley is smaller than the stock unit, so therefore my belt was actually, my tensioner was like almost straight down, like it wasn't even doing anything. The arrow up here was way off to the side over here, which told me my belt was way too loose. So I shortened the belt, and I think that did help a little bit. I did see a slight improvement in my voltmeter. All right, so I have everything disconnected, and now I just have to pull it out. Just in case some of you guys don't know, alternators are actually grounded to the back casing. So what I did was took my 6-gauge wire and I slid it in between the back mounting point. This way, my 6-gauge wire is grounded to the alternator going straight over to the battery, and it still has its mount. All right, I wanted to show you my old wire here. This red one's obviously the one I was running. It's 4-gauge. This is going to be my new one, which is the welding wire. You can kind of get a sense for how coarse the red one is compared to this new one here. The theory that I've been understanding was DC power actually travels on the outside of each strand of wire. So therefore, the more strands, the more roads on the freeway to travel. I'm going to be finishing the ends by crimping them with this copper lug. So what I'll do is I'll take my lug here and just kind of eyeball it to where I think the end of the wire is going to go, and then I'll just mark it. Next thing I'll do is take my razor blade and ever so lightly cut the end of this rubber off. And just like that, you can see the end of the sheathing is cut off, and I think my alternator is going to be happy. My lug fits on there just like that. Perfect. Okay, so I'm using what's called a hammer crimper. Now this thing is just what it sounds. It crimps by hammering. You just hammer it right there on the top, and it crimps your lug onto your wire. What I wanted to show you is that this piece down here has a couple steps, and that's for the flared end of the lug. So you can see right where I have the point of the crimp that's going to be on the lug, it's actually held in there quite nicely because this ridge is holding the flared piece. So I mean, I can yank on this and it's not coming out. And all you have to do at this point is hammer the heck out of it. Okay, there's the finished product. You can see that sucker is on there. You can yank and pull all you want. That will not move, it won't budge, it won't even wiggle. That's on there as if it's one piece. Look at the difference here, guys. I want to show you. My old wire was about twice the length as the new one, and obviously a smaller gauge. Okay, so I have my negative cable here. This one's going directly over to the negative side of the battery, and this is what I was talking about, where I'm going to put it in between the mount on the motor. But this lug is a lot thicker than the last one, so we'll see how this goes. All right, I'm stoked. That went in there perfectly well. Had just enough room on the end of the lug to line up the holes, and everything's working out great. All right, so at this point I have my main power line run from my alternator straight over to the positive post on the battery. I also have a ground from the back of the alternator right over to the negative post on the battery. You see that bolt that's about 3/4 of the way out there holding that wire on the chassis? I think I'm gonna go ahead and run a negative ground from that bolt on the chassis all the way up to the negative side of the battery. So what I have to do now is pull this bolt the rest of the way out, sand up the chassis so I can get a good metal to metal connection, and then make my wire. The last wire is made, and it looks great. I'm super happy. This is going to give a nice good ground from my battery to my chassis, something that I very quite possibly have been completely missing this whole time. Metal to metal, 2 gauge. That's gonna help out a lot, I think. We're all wired up. Every single end link is attached to the positive and to the negative there. Everything is nice and tight. I even threw some oil down on the bare metal down there on the frame. All right, guys, the moment of truth. Here we go. Well, that's good, it started up. Okay, let's keep an eye on our voltmeter. It looks like we're up at about 14 volts, probably 13.8, 13.9, something like that. All right, so it's been a few days since I've done the big 3 upgrade on my truck. I still have a few more things I want to do, like a couple more ground straps from the negative battery to the block and from the chassis to the block. I got this Klein amp meter. It's the CL800 and it measures DC amperage. You have to make sure that if you have an amp meter and you want to test the amperage on your vehicle, because all the power there is DC power, you need an amp meter that says that it does DC amperage. So I'm going to go ahead and throw the amp meter on directly on the power line coming out of my alternator. And I'm going to give it some revs. I have my headlights on. I have all the fans on high in the car. The AC is on and everything. We're going to see what my alternator is putting out and also what the fans are pulling. All right, so right now at idle, of course we're in park, so the RPMs are a little bit higher than they would be if I was in drive. But we're putting out 69 amps straight out of the back of the alternator. This is a 140 amp alternator by PowerMaster. It's a CS130. I'm going to go ahead and give it some cranks here. RPMs. 112, 113. So now let's test the fans themselves. All right, this is the main power lead coming directly off the battery for the fans. And it's looking like 34 amps. Okay, so I have the clamp meter around my main power line going into this fuse panel under the hood, and this one runs directly to the positive post on the battery. So nothing is on right now except the truck, obviously, and it looks like we're pulling about 12 amps. Okay, the fan's just kicked on, but that's a separate circuit. Headlights are on. We're at about 27, 28 amps is what I was seeing a second ago. So that tells me that the headlights are drawing about 15, 16 amps. Right now, the headlights are on, as well as the front and rear blower for the air conditioner. And you can see we're pulling 61 amps into the truck alone. Then when you take into account the fans, we're at about another 26, even I've seen it as high as 33 amps. So we'll call it about 30 amps. When you look at what the alternator is putting out at idle, and this is like a high idle because we're in park, we're only putting out 64 amps. Okay guys, so I did decide to change out the ground that was attached to the motor down there and over to the negative side of the battery. This is the cable itself. Pretty thick gauge cable, standard GM side post cabling. It also had this extra little body ground attached to it, and I'm going to redo that also. Alright, here's the finished cable. This old factory one does seem to be a roughly 2 gauge, but I doubt it's as fine of a thread of copper as this new one. So I went ahead and degloved this old stock wire. And for the most part, it looks perfectly fine. I don't think that there's anything wrong with this stock wire. I did not have to replace it. I didn't suspect it of acting up or anything. But for me, I just wanted to be sure 100%. And the only way to be sure was to replace it and cut this open and see. So this is, I think, 22 years old. Here's the other end towards the actual motor that was getting hot for all those years. And you can kind of see it's a little bit brown and corroded a little bit, but I don't think that really would have affected the performance of this wire. I think it was probably functioning just fine. I don't know. If you guys know any different, let me know in the comments. This job is complete. I got my new ground strapped to the motor down there. You can't really tell where it is, but it's there. and it's coming all the way over here to the negative side of the battery, and you can see this red wire is 4 gauge, and that's going to the body. Hopefully you can make that out down there. Well guys, that's it for this big 3 upgrade. I don't know if you want to call it a big 4, big 5 upgrade, whatever. I basically just upgraded my entire charging system. The only thing I still want to do is replace that braided ground strap wire that goes from the body to the chassis to the motor. Maybe I'll just leave that there and just add a ground that goes from the motor to the chassis or something like that. But for now, I'm happy with what I've done. I feel like there is no bottlenecks anymore, if there ever was, in my charging wire system under the hood. So I'm happy. Hopefully it all works. I think it's going to once I start the truck up, but it was fun. I love upgrading little things on my truck, things that will definitely help and reduce or remove bottlenecks of possible performance. So next thing I need to do is figure out my power issue from my alternator. I think that if I got a smaller pulley on there, it might help to spin that alternator at a higher RPM, thereby giving more power, more amperage at idle. So hopefully that'll work here in an upcoming video. But if you guys like this video, make sure you hit the thumbs up, it helps, and hit the subscribe, and I will see you in the next one. Stay tuned, there's gonna be many more. Also, don't forget to check the description below for information and links to the products I used in this video. All right guys, peace out.